Okay, bottom center of the screen. It's a new app, Don. I really appreciate the patience, man.
Okay.
Oh,
Oh,
okay,
very good.
okay.
Okay. Wow. Can you hear me now?
Excellent. Yes, sir, I can. How
Okay.
are you, my friend?
Oh, very, very good. Very sorry. I mean, apparently my Apple browser, Safari, just doesn't work. So Safari doesn't work.
Understandable.
I spent a half hour figuring out that Safari can't do this.
I appreciate you putting in all the work to do that. Man, I'm so excited for you to come talk with us. I really appreciate you spending Christmas time basically with us. How was your Christmas?
Oh, pretty good. It was good to see family and so forth. Family had to do a lot of driving because they couldn't fly.
Oh, yeah, 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 yeah. Right.
Right.
I don't like flying anyway, so all mine is driving. But yeah, we had a good time too. I'm glad you had a good time. So guys, let me introduce. Is it okay if I call you Donald or Don?
Don is fine.
Don is fine. Okay, good.
Yes.
I'm Thomas. Nice to
Thomas,
meet you, by the way,
great to meet
Thomas.
you,
Yep.
Thomas.
Yeah, great to meet you, man. Let's read off our friend's credentials here. Donald Hoffman is an American cognitive psychologist and popular science author. He is professor in the Department of Cognitive Sciences at the University of California, Irvine, with joint appointments in the Department of Philosophy, the Department of Logic and Philosophy of Science, and the School of Computer Science. He studies consciousness, visual perception, and evolutionary psychology using quantitative mathematical models and psychosocial experiments. What I want to talk to the most about today, I've of course watched your interview with Lex Friedman. I loved it. I didn't disagree with anything that you said. I'm very much a fan of your work. I haven't. I think you're brilliant. I think your work is brilliant. I haven't had a chance to read The Case Against Reality. I found excerpts of it online, but today, guys, we're going to be talking about his book, The Case Against Reality: How Evolution Hid the Truth from Our Eyes. And I want to read it, and I implore everyone who listens back to this or who's in the audience now, please pick up that book and read it. So, now that that's out of the way, have you got anything on your mind before I start drilling you?
No, I'm ready for the drill.
Okay.
Yeah.
Okay. So when I watched Lex, I love the way that the questions that he asked and everything, but sometimes can you go ahead and tell us the fundamental evidence that you came across in your studies through evolutionary game theory and evolutionary psychology, that gave you the case against reality? I know you mentioned um, we're not computational machines made to find the truth. We are using user interfaces on data structures. Is that right? Can you run us through that?
Right. So evolution by natural selection is now a mathematically precise theory. Right? When Darwin came up with it, it was not a mathematical theory to begin with. It was, Darwin was a naturalist and a brilliant man, but not a mathematician. But in the 1970s, John Maynard Smith, building on some other brilliant, prior research, um, really made evolution by natural selection a mathematically precise theory with was called evolutionary game theory. And so I decided to use the tools of evolutionary game theory to ask just a very precise question. What is the probability that natural selection would shape sensory systems to see true aspects of objective reality? Right? And well, sorry, my
Oh, dude, we're chilling here, man. There's no stress here.
right.
Go ahead.
So I decided, to ask that question: would we be shaped by natural selection to see reality as it is, at least in part, see some aspects of reality? And you might think, well, you mean, how could evolution answer that question? Well, it turns out it has the mathematical tools to do it. And so, and a lot of my colleagues who are experts in the area already have said quite clearly that there are lots of good reasons for evolution to lead us to have false beliefs. Steve Pinker, in his book How the Mind Works, goes into that in great detail. And Steve is a good friend of mine. my last year as a grad student at MIT was his first year as an assistant professor, and
Oh, that's awesome. I
yeah,
love Steven Pinker so much.
yeah, he's one of the most brilliant people I've ever met.
He really is.
Yeah, and I mean, I took a class with him. Then we became good friends, and I've known him ever since 1982 or so. And so his book really goes into it, but the one place where people have tended to draw back is to say, well, yeah, we might have false beliefs in a lot of areas from evolution, but surely evolution would lead us to see the true shapes and colors of everyday middle-sized objects like tables and chairs. And that was what I decided to just go and, yeah, hey, we all assume it, but let's go check it. Well, we have the math. Let's go do it. So I worked with a couple of graduate students. We ran simulations first, um, well, evolutionary game simulations and genetic algorithms. And it looked like organisms that we let see the truth were not out competing. They were failing to win against
Oh,
organisms that didn't see the truth and that just were tuned to the fitness payoffs. I mean, everybody believes that our senses are tuned to the fitness payoffs. And that's, I mean,
right.
that's what evolution does. But most people have assumed that being tuned to the fitness payoffs means you're tuned to the truth as well. And so when I got the work from Brian Marion and Justin Mark, their simulations showing that truth wasn't winning, then I went to Chetan Prakash, who is a mathematician and a longtime friend and collaborator, and we worked together. But he's the mathematician, not me. And Chetan proved a couple of theorems, which basically we can go into them whatever detail people want, but basically the theorems say the probability is zero that any organism has ever been shaped to see or perceive any aspect of objective reality.
I, I I don't disagree with you, and I remember your example on Friedman, how you said, this line in this
Mm.
probability space, right? If we can't talk about a probability space, we can't even talk about it. That line has infinitely many points, but it's a probability of zero within the probability space. Is that correct?
Right, that's right. That's right.
Okay.
So issues about what we mean by probability zero, for those who want, we can go into the technical issues, but sometimes it's a
Sure.
bit counterintuitive.
Sure.
But things that happen infinitely often can have probability zero. That's absolutely the case.
Birth of
Um,
the universe, maybe.
uh, right, and if people want to know how, everywhere we talk, there's a lot of depth, and so I don't want to just jump into things in great depth that are going to be boring to people. But if someone says, I want to know how things could be probability zero and have happen infinitely often, then we can go into it. But
Well,
otherwise, you can just accept it.
my friend, I'm okay with prima facie except exceptions. Maybe if a caller calls in and wants to get into some of the more technical on that, we can.
Sure.
But I've got so much to cover with you. You're more than welcome to go into it. As technical as you want to get, my friend, go for it. I love it. I absolutely love it. So, we in terms of like I didn't hear Lex ask this, so I'll go ahead and ask this. Obviously, you know plenty about way more than me about the philosophy of science, but I lean towards, in terms of the philosophy of science, I lean more towards anti-realism, constructive empiricism, instrumentalism, right?
Mhm.
Somebody holds a gun to my head. Okay, I'm a structural realist. All right, space-time is ontologically correct, and yeah, we've got reality. Do I think we have a one-to-one whatsoever? No, no, and I don't know if we ever will. As Kant said, the noumena. I see these data sets as similar to like the noumena. In some
Right.
ways, it's just it's a loose metaphor, but so what we perceive is an adaptive fiction. Can you go into that?
That's right. So most of us intuitively think that evolution would shape us to see the truth. That's how it would make us more fit. Surely, if you don't see the truth, you're going to lose against someone who does see the truth.
Yeah, you die off. Yeah.
You're going to die off. And so that's our intuitions. And and one reason we have that intuition is because we do have to take our perceptions very seriously. I mean, if you see a snake, you shouldn't pick it up. If you see a cliff, you shouldn't jump off, right? So, if you see a train, don't jump in front of the train. So we assume that because we have to take things very, very seriously, that therefore we should and we must take them literally, that they're literally true. And but instead, a different metaphor seems to be really helpful here. Um, what evolution has done, instead of giving us a window on the truth, it's given us a user interface. that hides the truth and just helps us to do what we need to do to stay alive. So if you're playing a virtual reality game, I like Grand Theft Auto, a lot of people use that, so it's a good one, right? So if you're playing Grand Theft Auto in a VR format, you see a virtual steering wheel and dashboard, and you see a virtual, Porsche driving next to you, and so forth. And when you're playing the game, of course, you're trying to win. You're hitting the gas. You're doing all the moves and so forth to try to win whatever you're doing. But what you're really doing and don't see is you're toggling millions of voltages in some supercomputer somewhere
That's right.
in a very precise sequence. If you toggle them in the right sequence, you lose. So you have to get millions and millions of voltages per second toggling in just the right sequence, or you lose. Now you could, if you could see the truth, you could get in there and try to toggle as fast as you can and get oh shoot, I got the wrong one. Oh no, let me start over. Well, good luck, right? It's
Yeah,
much easier to turn your steering wheel and step on the gas
that's right. The
instead of
user
trying to
interface, right? We can't just
use
go to the depth of the ontology of the PC, right? We can't do
that.
that. We can't
That's right.
transistors all the way up to the coding systems and the code compilers and all. We can't do that, you know. So
That's right. And so that's how evolution makes you more fit. It makes you more fit not to play the game of life, not by showing you the truth, which would be like toggling the millions of voltages in exactly the right order. Well, good luck with that. I mean, that's what you're doing ultimately, but you don't want to have to do it explicitly. So, just turn the steering wheel, press on the gas. So that's what evolution did. It gives us a very, very high level interface that is nothing like the truth, and that's who wins. Those who have to toggle voltages will die compared to those who just get to turn a steering wheel. And so that's the rough intuition about why none of what we see is the truth. So space and
wow.
time is not the truth. Objects in space and time are not the truth. This is just our VR headset.
I agree with you. I do not think that space time is fundamental.
Right.
So, I'm with you on that. Let's see. Let's go back because I had so many things. You talked about how. Let's see. I also think like how you said consciousness, the never-ending journey. You know what I mean? I
Mhm.
love that. I loved how you said that, or to those effects. We could talk about the philosophy of science, how there will always be a deeper understanding or theory, and so
Mhm.
forth. The peeling the onion back for infinity, and the onion just gets more complicated. But we want to go against this reductionist ontology, right? We want to try to think of what is deeper, what
Mhm.
is what is beyond that, and a lot of what I get from you is, within the conceptual, we're within Gödel's incompleteness theorems, but in the non-conceptual, we're beyond, right? So how do we get into the non-conceptual?
But that's right. So scientific theories are mathematical, and they have the ability to do sophisticated inferences and so forth. So Gödel tells us when you have something that's mathematical and that's sophisticated, it will necessarily be incomplete. Um, and if it's a scientific theory, then that means that the scientific theory cannot be a theory of everything. That's what Gödel's incompleteness theorem is really.
Uh,
So scientists who talk about a theory of everything is usually with a wink and a nod because they know that
tongue
there's
in
no
cheek.
such thing and so forth. This is there are a few take it seriously and they just don't understand the implication of Gödel's theorem.
Well,
So
good luck, like you say, right? Good luck
yeah,
on the
yeah,
theory of everything.
yeah. There is no theory of everything. So every theory has its limits. Every theory will come to the point where it explanation stops, and that's true of, for example, Einstein's theory of space-time. It turns out Einstein's theory is beautiful because it tells us precisely where it stops. It stops at 10 to the minus 33 centimeters and
Yep.
10 to the minus 43 seconds. That's where it stops. And then space time simply ceases to have any operational meaning.
Yeah.
So and that's going to be true of any good scientific theory. A good scientific theory, even though it's like Einstein started with space-time as a fundamental concept of the theory. That's so you go. So that's the fun. So that's what Einstein's trying to do. He's trying to get a theory of space-time. Great. Well, that theory tells you space-time makes no sense at 10 to the minus 33 centimeters. But that's what's going to happen with every theory. It's going to, if it's a good theory, it will tell you where the fundamental assumptions of the theory down. And
Yes.
with evolution, right, evolution starts with objects in space-time, like animals, and in modern versions, not with Darwin, but in modern versions, DNA. You know, they didn't know about DNA back then, but so in modern versions, there's DNA and cells and so forth. Um, and and yet that theory then tells us, I mean, using those concepts, it tells us that those concepts themselves are limited because nothing that you see is the reality. It's just a user interface. So it's telling you that the very language of evolution is only a language of an interface and that the reality goes beyond. Now, what's interesting is these theories, the theories in science can tell, a good theory can tell you its limits. If it can't tell you its limits, it's not a terribly interesting theory. Not a theory that I want to spend any time with. I like the theories that really tell you their limits. But the theories cannot tell you what to do next.
That's
Like they
right.
can't say, okay, like Einstein's theory, the quantum field theory says space-time is not fundamental, but it cannot tell you, okay, here's the next thing you need to go after. It can't tell you that. So you have to then take a creative leap, and then whatever you find beyond space-time, for example, you need to then show how it projects into space-time because that's where we can measure stuff.
Right.
And so that's what by the way, physicists are doing that, right? They know
Yeah.
that space-time is doomed, as they put it.
Yeah.
Space-time is not fundamental.
And these
And
are physicalists, right? These are people who hold to physicalism. So
yeah,
yeah.
or at least physicists, right? So
Yeah.
they're
Yeah.
doing
Yeah.
the science of physics. So
Yeah.
like David Gross said this in 2005. He won the Nobel Prize in 2004. He was very famous for his work in fundamental particle physics. I think quarks and so forth, the strong force. So
Hmm.
in 2005, which was the 100th year anniversary of Einstein's publication of his theory of space-time, special relativity. So, of course, David Gross celebrates the 100th anniversary, the centenary of this wonderful advancement and praises Einstein, and then goes on to say, yeah, but now space-time is doomed. And that's literally what he says in the paper. You know, thank you, Einstein, for this wonderful theory of space-time. Hats off. We congratulate you. Space-time is doomed. We need to move on to the next thing.
Yeah.
And that's the way science goes, right? Of course, you pay homage to the brilliant scientists who did all this wonderful work.
That's
You
right.
look for the limits and you break their theory and move on to the next theory. And
That's
so
science in a
physicists,
nutshell. Yeah.
that's science in a nutshell, and that's the spirit of science. And just in the last 10 years, they found a structure beyond space-time, a couple structures beyond space-time. So this
The
is brand new.
cosmological polytope, is that what you talked about?
Yeah, the cosmological polytope, the amplituhedron, and the deepest structure is something called a decorated permutations.
Oh,
So
okay.
decorated permutations are the like apparently the deep core of these structures.
Okay.
So it's like the deepest thing, and so the same thing is going to be true in evolution. So evolution tells us that okay, the objects like organisms and DNA, which are the fundamental language of this theory, are just interface descriptions. They're not the final reality. And the theory says, you know, if you want to find the final reality, you're going to have to look beyond this theory. The only thing that our current theories can do for us is they can tell you whether your next step is wrong. They can't tell you you're right, but they can tell you if you're wrong because if your deeper theory cannot project back and give you the theories that you started with, like if I propose a deeper theory, I say, okay, evolution is not the final word. I want a deeper theory beyond space time. Great, but you don't get to do whatever you want. Whatever you come up with, you have to project it back into space time. And if it doesn't look like evolution by natural selection, you're wrong.
Right.
So evolution can veto your bad ideas, but it
Right.
can't give you any good ideas. You have to go out there and find the good ideas for
Yeah.
yourself.
The unknown we have to kind of jump into. You know
That's
what I
right.
mean? And I think that's a little bit of what you're doing. You know how you talked about this user interface? Is there like so we are getting those fitness, what do you call them, fitness rewards?
Payoffs.
Fitness pay, yeah, rewards
Right.
payouts. Fitness, we're getting these fitness payoffs for these user interfaces, and which user interface is more reliable? Is that what it is?
Well, it's also which interface works best in your niche. So for example, if you're I think an E. coli bacterium, you don't need to have like complex eyes like we have. They have they're doing something very simple. They swim up a concentration gradient of some chemical that they eat.
Right.
And if they're and they just have this little rotor, and if they're getting lots of chemicals, they just keep doing what they're doing. But if the gradient starts falling off, then they just take a random, they change orientation randomly and start going. So whereas we hunt, we're looking carefully for our food and so forth, they just do random movements. And if things are going good, then keep doing what you're doing. So you can see
Wow.
everybody's got a different strategy with the E. coli. But see, humans, our strategy is to have just a couple kids, right? Maybe 10 if you're really prolific, but
Yeah.
one or two. E. coli, you're producing gobs and gobs, and most of your kids die. They're not kids. You're sort of like you're splitting yourself up in half.
Right.
You're, so you can either have a few offspring and be very, very careful with them, try to raise them to maturity, or you can make many, many, many offspring and throw them to the wind, and a few of you will make it, and most of you won't, and that. But as long as there's a lot of you, then our species will. So you can see there's no one right strategy. There's many, many different strategies, and
So
ultimately,
those people could have passed their genes on, basically, right? Yeah.
absolutely,
Yeah.
absolutely.
Yeah. Okay.
And so 99.99% of all species that have ever been on the planet are extinct. So that's what ultimately happens, right? Every strategy ultimately doesn't work.
Yep. That's right. I mean, that seems to be what nature is doing,
Right, right.
whatever nature may be ontologically. Um, so, like you said, these user interfaces, are these data structures obviously within the substance of reality, which would be consciousness for you? Could I call you a neutral monist? Could I could
Uh,
I could I call you a consciousness monist?
Probably more closer to a consciousness monist than a neutral monist.
I'm not labeling you. I just wanted to ask just for my understanding. Thank you. So, you know, as you said in the podcast, future scientists are going to laugh at us. You know what I mean?
Sure.
So we shouldn't have dogma, and like you said, if it can't come back into the theory and work within that realm of space time, then it shouldn't be, or work within the realm of evolution, it shouldn't be taken seriously, right? Is that
Right.
what you were getting at?
That's right. Whatever new theory that see, so the way science progresses is that we don't throw away our old theories that were good theories. We don't throw. I mean, we still use Newton, and we still love Newton, even though Einstein completely transcended Newton, and so forth. But you had to show with Einstein, you can show how Newton can be seen as a special case, is what, like when the speed of light goes to infinity, then you get sort of Newton as a special case, that kind of thing. And so whatever new theory that we come up with beyond space-time, and the physicists have found that amplitude-hedron, for example, and decorated permutations, but what they're doing is they're showing how they project back into space-time and predict what we already can see in space-time, like scattering, like when in the Large Hadron Collider, two gluons hit each other and four gluons go spraying out, that kind of thing. Stuff that we can already compute using space-time tools. They now have to show how you can compute the same thing with these new tools that are entirely outside of space-time. And so they do it. They say, with these new tools, we can actually predict what you're going to get at the Large Hadron Collider in terms of these scattering events. But we can, and it turns out it's easier. It's when you do it outside of space time, the math becomes much, much easier, and
Less
you see,
variables. Okay.
yes, and new symmetries that you can't see inside space time.
Okay.
So and this is, by the way, this is brand new. That the paper on the amplitude-hedron and the decorated permutations related to it is less than 10 years old. So this is all brand new stuff.
Yeah.
And many physicists are not aware of it. This is a specialty of high energy particle physics.
Yeah.
That's where this stuff is really known. And but their physics is a very, very big field, and a lot of physicists that I've talked with and asked them about this don't even know about it yet.
Yeah.
So,
Oh
so
yeah. I mean, and that's going to be the thing. Any fringe anything is, even if it has so much clout behind it, is going to be fought tooth and nail. You know what I mean?
well, um, in the physics community, when someone can actually predict all the amplitudes and do it with um, much. So when you do the two gluons in, four gluons out that I was mentioning in using space time, it's hundreds of pages of algebra.
Oh
When you
yes.
do it with these new structures, the brand new structure they found outside of space-time, it's 3 terms you can write by hand. So hundreds of pages of algebra gets collapsed to just 3 terms,
Yeah.
and so no one's going to argue with that. If you can make me do the math trivially compared to something that a supercomputer can't do, then I'm all ears. Right? And so they're all the ones who need this stuff, like the particle physicists, the high energy particle physicists, are all over it, and this is taking over. So yeah, they're not going to be arguing against that. Now, in my field, the work on evolution, though, is taking harder. It's taking longer for people to come around, because this really hits us where we live, right? I mean, I don't
Hmm.
see reality as it is. Give me a break.
Hmm. Yeah.
If you don't think that train is real, why don't you step in front of it? Why don't you
Right.
jump off a cliff? Right? People have all these kind of arguments, and philosophers as well will argue. Look, the theory of evolution assumes that there are objects in space-time. So how could it prove that there are no objects in space-time
That's
without
right.
contradicting
It's
itself?
assuming it prima facie, right? So
That's right. So how can you do this without contradicting yourself? And and the point is, every good scientific theory will tell you the limits of its fundamental concepts. That's not
yeah.
self-contradiction. That's
No.
the glory of science. Um,
Agreed.
it, it, to say that you couldn't use your theory to show the limits of your basic concepts would mean, um, well, that Gödel's incompleteness term was wrong,
Well, you wouldn't have a theory that could predict anything useful, would you?
right? Because you're going to always have limits, and if you can't tell your own limits, then you're not predicting the one thing that's the most important thing to predict.
Yeah. I believe that, and falsification being like the main the main the so okay, so our user interfaces are what are these things that we have. I mean, we're obviously still biological matter, right? We're not just a series of user interfaces. Is that
Well, so our interface gives us a picture, an avatar of ourselves, and that avatar of ourselves is biological looking avatar. So I'm not my body. My body is just an avatar. Like if you're in a virtual reality game and you see your avatar in the game, right? There are times when you lose yourself. You get so immersed in the game that you identify with the avatar, and if something comes and actually is threatening to like chop off the arm of your avatar, you might actually flinch. You mean you might have a knee-jerk reaction to flinch. So
yeah.
you've really identified with your avatar. Well, we're identified with our avatars, but and their biological nature, but the identification is false, just as your avatar in the VR game
Yeah.
is not who you really are.
Well, I think philosophically, we only have access to the phenomena of the sensory network that we're taking in this information. So anything outside of that, how in the hell do we know what that is? You know what I mean?
Right,
So
which is the question that you sort of started off with, which was, so how do we get in touch with this reality beyond the phenomena, right?
yeah, yeah,
Right.
yeah, exactly. So like you said on the space time is a user interface, right?
Yes.
Okay. So dark matter and dark energy are hidden from our user interface. So that's something
Right
right
now,
there that's
absolutely. Right
yeah.
now, we don't
You know
know
what
how
I
to.
mean, right? At least in the terms of reductionism, in science. And I loved what you said. You said maybe evolution is a deeper theory about cooperation. We don't know yet.
Right. It seems to me quite possible that we could have a theory outside of space and time of conscious agents that are cooperative, for example, and we have no limited resources. And when you take a projection of that into some interface, that the fact that you lose information in the projection could make you see illusory a world in which there is competition for limited resources and nature red and tooth and claw.
Right.
But to be explicit, I'll say something very technical here. It's possible to have a so-called Markovian dynamics of these conscious agents that I'm working on that has no arrow of time, no increasing entropy. Okay, so there's no entropic arrow of time. And yet, when you take a projection of this dynamics by conditional probability, so you get a new picture of the dynamics. You see this little dynamical system that's a picture of the big dynamical system, but you get it by projection. The projected dynamical system that you see will have an arrow of time as an artifact of the loss of information that happened to you when you did the projection. And so the arrow of time is not an insight into the nature of the reality that you're looking at. It's entirely an artifact of the projection process.
Okay, it's entirely an artifact.
Entirely
Okay.
an artifact. And my guess is that pretty much everything that we see, even the way that we carve the world into objects, not so time is an artifact, but
Right.
even the way we carve the world into objects is an artifact of our projection and not an insight into the ultimate nature of reality. So
Mm.
we're this is entirely illusory in that sense.
No, I mean, I don't disagree. I mean, I really don't. Um, that's so beautifully said. I can't even say anything after that. So you talked also about, and I don't want to keep you to. I don't even know how long you can be with us today, my friend. I love this. I'm having such a good time. Here in a little while, if you can stay with us, we'll have a few callers. I don't know how many we'll have, but this is
Okay.
still a platform that's in beta, so we're still running a lot of stuff here. But I
Okay.
wanted to go over a few more things because just
Sure.
I love this so much. Um, Portals as user interfaces, how we see portals. Can you explain that a bit?
That's right. So space and time is just a headset, but it does give us access to other people's consciousnesses. So, for example, right now, uh, I'm talking with you, and all I'm seeing, I've got a flat screen on my laptop here. That's all I inside. There's some pixels on my screen, and I can see some pixels that represent your face, and some others that represent a wall behind you, and a poster on the wall, and so forth. Yeah. So now, so some of those pixels that I'm looking at give me insight into your consciousness. I mean, I can see you smile or nod or frown, whatever it might be. So it's not infallible, but it's a genuine access to what you're experiencing, what your moods and so forth. Whereas the pixels that correspond to your ceiling are not giving me any portal into consciousness of what they're just sitting there. Now it would be silly for me to say, okay, so some pixels on my screen are conscious. No pixels on my screen are conscious. They're just pixels. They're providing a gateway, a portal to consciousness, but the pixels themselves are not conscious.
So it'd be like saying the photons that are bouncing off the screen and coming to your eyes are conscious, right?
Yeah, that would be the same mistake. But
Right.
so now, if I'm there in person with your avatar, and I say, well, look, that body is conscious, but the chair is not. Well, once again, the body is just a portal. It's just like the pixels. It's just a user interface avatar. And so certain certain objects in the interface provide us more insight into consciousness, and others provide us less. A rock provides me basically no insight, but but I'm the theory that I'm proposing is that consciousness is what's beyond space time.
Well, is rock the data structure?
So rock is just a data structure, and
Okay.
it's just such a poor data structure that it gives us no insight into the consciousness behind.
But
So I'm
but
not saying a rock is conscious or that a rock has consciousness inside it. So this is
no.
not panpsychism. I'm
Yeah,
not
I know you
proposing
don't take the pan. For anybody in the audience listening, he is not taking
uh,
the panpsychist route on this one for sure. So
by the way, I have good friends that are panpsychists. They're
yeah,
brilliant people,
I do
good
too.
friends, and we agree to disagree.
Right, right. Well, most of your contemporaries and colleagues are, like you said, 95, 99% physical monists. They think that consciousness is not the deeper realm, that it's more reductionist ontology, 10 to the, like you said, it would be impressive if somebody came to me with 10 to the negative 33 trillion. You know what I mean?
That's
you
right.
know
So yeah, space-time falls apart at 10 to the minus 33 centimeters, which is
Mm.
shallow. Well, I view that as we got cheated. We have a really trivial, low-tech space-time headset. As I said, if it was 10 to the minus 33 trillion centimeters, that might be more impressive, or 10 to the minus 33 quadrillion. That would
Right.
be a more, but this is 10 to the minus 33. The only reason we're impressed with it is because our current technology is so trivial. As soon as we have technology that can start to push things, we'll come up to the limits of our headset, and then we'll go, what gives here? Who this is,
Yeah.
it's only 4 dimensions, maybe 10 or 11 if you think
Yeah, if you
in
string
terms of
theory, yeah.
strings.
Yeah.
But at most 11 dimensions. I would love to be able to see in 35,000 dimensions. Why not?
Wouldn't that be awesome? I
Yeah.
think about that all the time. I mean, I don't necessarily know if I can put a limit on dimensionality, but I understand it deals with geometric patterns and things like that we can't just out, you know. But so obviously, space time is a useful tool, but not fundamental, as far as you see it, and as far as your
Mhm.
the evidence from your experiments have shown. And you said the biggest pushback was from Yale. Can you explain what they pushed? The best part of their pushback?
Oh yeah, and we're writing a paper now to reply. And this is, this is all good stuff. I mean, this is the way science works. So it's good for our scientific colleagues and friends to push back. And so the technical pushback from Yale is and this gets a little technical, so I'll go into it, but stop if it starts getting too much into the weeds.
Anybody, we can handle it, my brother. Go for it.
Okay, so we in our simulations were focused on a single fitness payoff function. We showed, in the our evolutionary game, genetic algorithm simulations, when we just used one or two different fitness payoff functions, that if you were tuned to the payoffs and not to the truth, you would win. So the Yale team said, well, look, suppose that you have thousands of different fitness payoffs that you have to deal with for different goals that you're trying to reach and so forth. What if you had thousands of them? And they also say, suppose this gets a little technical, but suppose that our perceptual systems are what they call cognitively impenetrable. And this is a lot of my colleagues and friends think that our cognitive systems cannot change our perception. So what I believe won't change in general what I see, for example, or what
Okay.
in general, I can't see what I want to. So there's a line in front of me. Well, I don't like it. I would rather see, a nice 5 course meal, gourmet meal, instead of that line that's about to attack me. So I think I'll try to. No, it doesn't work, right? The line is there regardless of what you wanted to see, and so there's no what they call cognitive penetration of perception, or very little cognitive penetration of
Can't
perception.
force yourself to believe so. Like I can't force myself to believe that I can fly right now, kind of thing.
Uh, that's right. So, the idea is your senses are going to do whatever they do, independent of what your high level goals are,
Yeah.
and so they argue from that therefore there can be only one mapping from the external world, the stimulus, into your percepts. So if there's no cognitive penetration of perception, then there is only going to be one mapping from the world, whatever the world might be, to your perception, say of a lion or whatever it might be.
Mhm.
So, and then they show that if you force a system, an organism, to have only one mapping, and you show it thousands and thousands of fitness payoff functions, but say your perceptual system has to evolve with only one mapping, then
Mhm.
then they show that in that case, um, the in the limit, or if you choose very, very careful functions very, very quickly, payoff functions, then you will be more tuned to the structure of the truth than to the payoff functions. And so there's the, we're going to do our reply, and we're writing the reply right now. But I can say at
Okay.
top level the things that we're going to do in our reply.
Yeah,
And,
please
and
do.
by the way, the lead person, the professor at Yale, whose graduate students work with him on this, is a good friend of one of my colleagues on the paper, and I mean they were friends at in Cambridge. My graduate student, Manish Singh, was at MIT as a postdoc, and Brian Scholl, the guy
Yeah.
who's now at Yale, he was a postdoc at the same time, but he was at Harvard, and so Manish and Brian are friends, and so we'll argue with each other, and then hopefully someday we'll get together and you'll have dinner, and you
As
know
long as the data is being taken seriously, that's
yeah,
all I care about. You know what I mean?
that's
And
right.
that's a good thing.
Yeah,
So,
so there's nothing personal here. It's all you know it's all cordial, and we're glad that Brian has thrown down the gauntlet, and so we're now
well, I'm
um,
happy to hear I'm happy to hear the response. You don't have to lay it all down here, but I understand. It doesn't really how many they add. Could they add a billion and it make a difference?
right. So, well, what we're going to do is we're going to show that first, it's simply not true empirically that we have only one mapping from the sensory stimulus to the percepts. So, and I'll give you a concrete example of this. There's some beautiful work done by Pawan Sinha at MIT. picking up on an old philosophical chestnut that Molyneux, it's called the Molyneux problem. Molyneux
Okay.
asked, suppose that a man born blind, say due to cataracts, and as an adult, his eyes are corrected, so they can see for the first time. And the question, can he tell by looking, just by looking now, um, which object that he sees will feel like a cube and which one will feel like a sphere? So I've got a sphere and a cube in front of him. And so he fills them, and the question is, can he match what he sees with what he's going to feel just by what he first sees? And so John Locke said, I don't think so. I think that he'll have to learn the association. And also Berkeley thought so, and so he's a very
Yeah,
famous
yeah.
British. So Pawan Sinha went ahead and did the experiment. He went to India, and they brought some surgeon, I guess, who could actually correct the eyes, and they actually helped some young people. They gave them their vision back for the first time, and they did the test. They did and it turns out that they were at chance. You give them a bunch of objects, and they're completely guessing. Now, a week or two later, they've learned, right?
Right.
So here we have, from a physicalist point of view, there were just there was one object. There was a cube, say, but you had a visual representation of the cube and a tactile representation of the cube,
Right.
and you didn't know that they were the same object.
No, not from
So
that point of
here's
view.
there's a complete contradiction to the claim that there could be only one mapping from the stimulus into a percept.
Yeah.
Well, here's a clean case where there's one stimulus going into two percepts, but then so that's just our opening salvo. Then
Good.
the next step is going to be to say what we call physical objects. What are they? They are, in fact, when I look out into the world, I'm facing, if you will, lots of different payoff functions. What do I do? Well, one strategy is to use all of them and see all the thousands of fitness payoff functions.
Right.
Another one is the Brian Scholl strategy. You'll sort of collapse them all into one and only choose one. But what if we do something in between? What if we group our fitness payoff functions into clusters? These payoff functions are very, very similar. These are very, very similar. They have similar, and so maybe we can do an approximation to these fitness payoff functions. And for these goals, we can, it won't be exactly right, but we'll be getting a lot of the fitness payoff. So that's what we call physical objects. Physical objects are the data structure that you get when you collect fitness payoffs and make them into units. And we
Yeah.
have about 30,000 different basic physical objects that you can recognize. And so this is how we sort of take these fitness payoffs. We do what's called hierarchical clustering. And so all the objects that we see are just examples of the multiple fitness payoffs and how we deal with it.
And the
So
data structures that those,
yeah,
yeah.
so
Man,
it's
that's
certainly not
brilliant.
true that we're stuck with one fit.
Yeah.
There's not one mapping. We have 30,000 mappings just for the objects, and then different senses and so forth. So we have lots of mappings from the objective world.
Is it potentially limitless mappings?
Um, well, for humans, we seem to, we have
I know
80
you said
billion neurons.
consciousness, or excuse me, I know you said human consciousness is one drop in the bucket. I get that.
Right, right.
Maybe my question wasn't as salient as it needed to be, but
Right. Well, if we just if I try to answer your question just now, sort of being just a biologist kind of thing, and saying, as a biological organism, do we have unlimited capabilities? And the answer is we have only 86 billion neurons and trillions of synapses, and that might be impressive, but it's finite. So the
right,
answer is we have finite capabilities, big but
right,
finite.
right. Very big, but you're
That's
right.
right.
All right, so I'm going to ask you a couple more things. I kind of wanted you to, how people in reductionist physicalism, they're obsessed with size. The smaller we can get, the more we'll know about reality, or the bigger that we get and know more about that, we'll know more about reality. Why is that? Why does that not matter?
Well, it's been up to a point very, very successful, right? The reductionist approach is fantastic. For example, in thermodynamics, it's so what is heat? Well, Boltzmann and others showed us that if you think about air is a bunch of molecules bouncing around, and the mean molecular kinetic energy of those molecules is roughly what we, of course, call heat. And that's an incredible gift. I mean, that was really brilliant. And so that strategy has been useful in many areas. So I'm not dismissing it out of hand. But what happens is, since space-time ends at 10 to the minus 33 centimeters, right? That you can only go so small, and then reductionism just plain stops. And so as a fundamental approach to science, it cannot work because it only works down to 10 to the minus 33 centimeters, which, as I said, is a very shallow data structure. It's extremely shallow. So
Could
it
we?
must work just a little bit.
Right. Could we? I mean, obviously, we could get our math more precise, and we could change it because we have new paradoxes that we learned. We could solve millennial math questions, things like this, right, and get closer to. But that still is technically just making the ontology smaller. We're not necessarily finding the deeper nature of reality, right? We're just
If, that's right. If you're trying to just find smaller and smaller objects in space time, like smaller and smaller particles, so we found molecules, and then we saw, oh no, they're made out of atoms. And then, oh no, those are made out of protons, neutrons, and electrons. And then, oh no, the protons and neutrons are made out of quarks and gluons. And then we say, well, right now quarks and gluons look to be fundamental, but maybe in 20 years we'll go, oh no, quarks are made out of and so but we know that whole approach is going to stop,
yeah,
because it has to stop at 10 to the minus 33 centimeters, because there's
yeah.
nowhere else to go. And physicists already have good examples of where it starts to go the other way. It was something they call the UVIR correspondence. So you go smaller and smaller, all of a sudden you start going bigger and bigger and bigger, right?
Ah,
Right.
okay. Like macroscope into the micro and out to the macro. I got you.
That's right.
Yeah,
And in fact, for example, if you're trying to measure things at a really small level, like at the 10 to minus 33 centimeters, what happens is you're putting so much energy into such a small region of space that you create a black
right.
hole. So
Yeah,
that's why space-time ceases to make sense. Is that you create a black hole, so that and if you say, well, I'm gonna try harder, I'm gonna put more energy in there, try to probe deeper, the black hole just gets bigger and bigger and bigger. So all of a sudden you're trying to go smaller, and nature comes back and says, no, you're going bigger and bigger and bigger. So
yeah,
you're no longer reductionist. You're not going reductionist. You're going the other direction.
yeah. You're going macro. Yeah, I got you. That's man, that's so insightful as hell. I love the way that you think about that. Um, so a couple more things, and then because I know everybody. Well, we don't have any callers chasing us, chomping at the bit, if you will, right now. So I'm gonna keep going as long as you're still having a good time, man. I don't want to. I don't want to
Yeah,
keep you too long. Please let me know if you have to go or anything. Please do. Um,
probably
quanti-
around my time, by about three
okay,
months.
so another 30, 40 minutes be okay?
Yeah.
Sure, sure. Okay, good. All right. Consciousness qua consciousness. Now I know being qua being from Heidegger, right?
Mhm.
So that's more fundamental. What it maybe it creates all data structures?
Right. So what my team is proposing is that consciousness is fundamental, not space-time. So consciousness is outside of space-time. We're trying to show how space-time emerges as a data structure that consciousnesses can use to interact with
Yeah,
each
the
other.
backwards problem of the
Yes.
for the audience, hard problem of consciousness is how does consciousness arise from non-conscious matter? Our
Right.
friend Don here is going backwards. He's saying, "Well, go ahead, Don. I don't want to put words in your mouth."
Right. Yeah. So most of my colleagues think that, for example, brain activity causes conscious experience, and and my attitude is that, well, brains only exist when they're observed. Brain is a user interface symbol that I create when I happen to look, just like in the virtual reality Grand Theft Auto game. When I look to the right and I see a red Camaro, well, I render the red Camaro when I look, and then I garbage collect it when I look. Now I'm looking and see a
That's
green
right.
Porsche from the left. Now I'm rendering the green, and there is no red Camaro anywhere when I'm not looking. There's not in the
That's right.
supercomputer. You can
So
look in the
right now, I
supercomputer,
can't look at your head and see your neurons unless you know what I
right?
mean, or I can't even look at the wall and see your. It's only when I perceive your neurons looking through a
Like
microscope or
microscope.
whatever.
That's right.
Yeah, that's when the data set goes through my user interface and sees a neuron. Right.
That's right. So
Okay.
neurons don't even, from my point of view, neurons only exist when they're perceived. They don't exist when they're not perceived. And I'm a cognitive neuroscientist. I love neuroscience, and I think we need more funding for neuroscience because neuroscience is a lot harder than we thought. We thought we see 86 billion neurons, and that's because there are, in fact, 86 billion neurons. No, we see 86 billion neurons because that's the trivial representation that our interface can come up with. Whatever is really going on is much, much more complicated than
Yes.
86 billion neurons. That's just a surface uh, wash on something that's much more complex. So we're going to need a lot more effort in cognitive neuroscience than, and so neurons cause none of our behaviors, and the neural correlates of consciousness are just the neural correlates of consciousness. They're neurons
Yeah.
cause none of our behaviors,
Yeah.
and so that's a physicalist, and most of my colleagues are physicalists, and
Right.
they're brilliant, and the reason they're physicalists is not because they're dumb. They're many of them are geniuses. Is that
Well, something you found out something very new, my friend. You know what I
yeah,
mean? You're coming onto a very. I mean,
yeah,
in the next 10 years, I expect people to be talking about this a lot more. But go ahead. I'm sorry.
yeah. I hope so, but our attachment to space, time, and physical objects, it goes very, very deep.
Very deep.
So it's not just intellectual; it's very emotional. The reaction to these ideas is very deeply emotional. People get upset, they get mad, they get scared. It taps into a wide range. And by the way, I felt all the emotions. I mean, I'm like everybody else. I still, I don't think my emotions have come to terms with this yet. My head has, but my emotions still in the moment believe that I am just my body. They believe that the sun is there even when I'm not looking, and the whole bit. Um, but anyway, so my colleagues are brilliant, but the reason they still buy into the physicalist idea is that it has been so successful for 300 years in science, and we've had no alternative until the last 10 years. And even most physicists don't know about the alternative, right? They don't know
No.
about, if you I did this at a conference I was at a few months ago where there were a lot of quantum theorists there. It was a conference on consciousness. So there were many professional quantum physicists there. And so I asked many of them, as many chances I got to ask questions, I would ask them, so what do you think about the structure beyond space-time, the amplituhedron? And none of them,
None of them
none
knew it.
knew about it. That's right. So my colleagues in cognitive neuroscience can be forgiven if they don't know about these structures beyond space-time, because most physicists don't know about it either.
Well,
But
your
so it's going
work
to take a
requires you
while.
to know all this stuff. You know what I mean? Excuse me. I'm sorry to interrupt you. That your work requires you to understand the physics and the evolutionary game theory and the consciousness part and the cognitive neuroscience part. All of it.
That's right.
I think it's super important.
Yeah, it's multidisciplinary. Yeah, to do it.
Multidisciplinary. Exactly.
That's right.
Um, I didn't want to cut you off. Did you have anything more to say on that? That was
Well, I'll just say that I think that it's going to take a while for my colleagues in cognitive neuroscience to move in this direction. Um, the physicists, if quantum physicists don't even know about it, it's going to take them a while. Probably it'll take 10 or 15 years for the quantum, all the quantum physicists to really understand that the revolution has happened and it really is important for them.
yeah,
And then it'll probably take another 10 or 15 years after that.
yeah,
I mean, I hope I'm wrong. I hope it happens much more quickly.
yeah.
But my guess is it's going to take decades. And what's unfortunate about it is that I mean, I know I'm good friends with many of the current cognitive neuroscientists, and I mean they're really really smart, and they're
Yeah.
really talented, and they're being stymied not by a lack of intelligence. They're being stymied because right now science has forced them to have the wrong assumptions. You can't, if you start with objects in space-time, you cannot boot up a theory of consciousness. It's impossible because you got the wrong starting point. And so as smart as they are, they can't do it. And so what's sad for me as their friend and colleague is that they don't get to use their brilliance in a way that's going to actually produce something, and I don't get to read their brilliant papers that could actually make progress on this thing.
The
We're
the
forced to rely.
physicalism indoctrination, right?
Well, yeah, we're going to be forced to be studying, looking at papers where we're trying to figure out how neurons might do this, or how circuits in computers could somehow give rise, and eventually we'll realize, wow, that the whole thing was just on the wrong foot to begin with. We needed to
Mhm.
think completely outside of space time. The physicists have been there for 30 years. Maybe we should catch up.
Yeah, yeah, and I love it. Space time is doomed. I've looked at a lot of papers since studying your stuff. They do say that,
Oh
and
yeah.
I can agree. I agree that space time is not fundamental. I think it's deeper than that, whether it be consciousness or something else we can't explain. I'm not being religious in any way. I'm just saying I am being purely scientific. I think that space there is something more fundamental than space time, and I'm leaning after reading your stuff and other people's that it is consciousness. I just some people, especially the detractors on here, people that I've argued with hundreds of times, uh, they would just say this is idealism in a lab coat.
Well, so the reason I don't call myself an idealist typically, I call myself a conscious realist. So
There you go.
I'm thinking
Yeah.
consciousness is real.
Yeah.
The reason I don't call myself an idealist is that idealism has a long and checkered history in philosophy, and it means a lot of different things to a lot of different people. And one thing that it often has meant is an anti-realist point of view. So it's been conflated with anti-realism, and also in many cases with anti-science.
Mm.
Many idealist philosophers were, in some sense, idealist in reaction to the
The
physicalist science.
analytical philosophy. Yeah.
Right, like so, Berkeley, who was brilliant, was in part motivated, maybe highly motivated by his religious beliefs, and also his attempt to defeat what he thought was the terrible mechanism of Newton, which he thought
Right.
was going to have wrong, spiritual implications and so
Right.
forth.
Right.
And so idealism has historically been associated with non-rigorous theories and at the best, and anti-scientific sentiment at the worst.
Yes,
And
I
and
agree
I
completely.
disagree with both. I mean, I think that if we're going to take consciousness as fundamental, we should be absolutely mathematically rigorous. And this is not anything against science. It's a completely new theory. Science is a method, not a theory. Science and physicalism are not the same thing.
That's
Science
right.
is a method.
Yeah.
It's a way of inquiry.
Yeah.
It says, be precise, tell us where you're going to be wrong, tell us an experiment we can do to show that you're wrong. That's what
Perfect.
science is about.
That's
And
yeah.
physicalism has just been a very useful framework for 300
Yeah.
years that just ran out of usefulness. Now it's now time to move on to a new framework.
People
Um,
have to change this mind. Well, I agree with you. People have to change this mind of substance. Is it all ideas? Is it all physical? Is it all consciousness? Is it, you know what I mean? We have to have these boxes we fit things into where it could be something much more amorphous and vague, like you say, the non-conceptual,
mhm,
the realm in
right.
which Gödel's and completeness theorems don't play around in. Only a couple more things, man, and I've pretty much asked everything I can. Um, you did say anything that we can do with neural networks, we can do with conscious agent networks.
Mhm.
Yeah,
That's
you
right.
want to
So
expand on that?
yeah, so we've published a paper. People can, if they want to see the math, you can just Google. The title of the paper is called "Objects of Consciousness." So if you just Google "Objects of Consciousness" and my name, it'll come right up, and it's free. So anybody can just get that for free. And you'll see there we propose a mathematically precise theory of conscious agent networks. And it's once you look at the math, you'll see it's trivial to show that it's computationally universal. Anything you can do with networks of neural networks, you can do with
Yeah.
these conscious agent networks.
Does
And
Wolfram agree with you on that? Wolfram probably agrees with you on that, doesn't he?
well, I doubt that he would disagree. I mean, it's just sort of obvious
Yeah.
that they're computationally universal.
Seems trivial, yeah.
Right.
Um, so you explained the backwards hard problem of consciousness, right? We talked about that as much as you feel like you need to cover, or is there anything else that
Well,
you'd like to say on that?
I'll just say that the standard view is trying to show how consciousness arises from complex physical systems like neural networks or systems with the right causal architecture. So integrated information theory, which Giulio Tononi and his colleagues are working on, um, uh, uh, says that if you have a system with the right causal architecture, or what they call the right Q shape, you get a specific kind of conscious experience. Um, the problem and there's other theories like the orchestrated collapse of quantum
Yeah,
states.
Orcar. Yeah.
Yeah, Stuart Hameroff and Roger Penrose.
Yeah.
The problem that these approaches have is what I would call the stipulation problem of consciousness. They stipulate physical systems like neuronal microtubules. So physical systems like quantum states of neuronal, not microtubules, or whatever physical thing has this causal architecture. Then
Right.
they posit certain functional properties like the orchestrated collapse or the integrated information, and then they have to stipulate the conscious experiences because there's not a single specific conscious experience like the taste of vanilla where you can say this is the Q shape, which is the integrated information pattern.
Yeah.
This is the integrated information pattern, the Q shape. That must be vanilla. And here's the principal reason why that could only be vanilla and could not be the
Yeah.
smell of garlics. There's nothing on the table like that. Nothing.
You can't get qualia from Orcar or anything else like that.
Not
There's
one. So these are
not
theories of
one.
consciousness that cannot give you one conscious experience. Not one. So they have to stipulate every conscious experience is stipulated because they can't boot it up.
Yeah, they can't give
Every
it to you.
functional property is stipulated, and the space, time, and the physical object they start with are all so they're stipulating everything. So that's what I call the stipulation. So there's nothing's being explained. No specific conscious experience is being explained. It's all so my attitude is okay. Since they're stipulating the conscious experiences and all this other stuff, I'll just stipulate conscious experiences and none of the other stuff, and then I will actually show how space time emerges from the dynamics of conscious experiences. And so I'm stipulating less, so I win by Occam's razor, right?
Occam's razor. I was about to say,
Right, right,
technically, you do win because
right.
the less we multiply entities, necessarily. Man, dude,
But by the way, that doesn't mean I'm right. It just
no,
means that according to Occam, I'm not as wrong as them, right?
right?
That doesn't mean. And by the way, my theory of conscious agents is not a theory of everything. It has definite limits, and if you wanted to, I can tell you precisely what the limits are. So I know that my own theory has limits, and it tells you its limits, and so I will be looking for a deeper model. But right now, I'm trying to figure out and explore this model because I need to explore it to its fullest, so that it can then tutor me when I start to make leaps beyond the conscious
Yeah,
agent
your
model.
stepping stone.
I
Yeah,
need to be able to pull it back into the conscious agent model, which I need to then be able to pull back into space time.
yeah,
This is
yeah.
how you make this is how you make intelligent forays into the unknown.
Yes.
If you just throw darts into the dark, good luck. You need to have
Yeah.
a little bit of guidance where they can't tell you you're right, but these theories can tell you when you're wrong. And so
Yes.
that's what you need are the theories that tell you when you're wrong. Because of course, ultimately, you'll never be right. No theory is ever going to be a theory of everything.
Nope. I agree with you. I don't think there's ever going to be a theory of everything because
Right.
in reductionist ontology, it can always just be that. You know what I mean?
Right.
So I'm super interested in where this work is going. I want your book, so I'm probably going to order it and read it. When is your next work going to come out? Are you going to publish any of the stuff you say to Yale, or are you going to?
So we have a paper under review right now with the journal Entropy. It's called Fusions of Consciousness.
Oh,
Yeah, yeah, that's the title of the paper, Fusions of Consciousness. And we make what I think is a fundamental advance. I'll just state it real simply. The physicists have found a deep structure beyond space-time called decorated permutations. And decorated permutations, in some cases, give you all the information for computing a scattering amplitude, like two gluons hitting each other, four gluons going out. In the case of so-called n equals 4 supersymmetry with massless particles, the decorated permutations are all you need to compute the scattering amplitudes. For particles with mass and spin, you need to add mass and spin.
hmm.
And so what we did was we said, okay, the physicists are already finding these structures beyond space-time. The decorated permutation is as deep as they've gone. We have this Markov dynamics of conscious agents that's also beyond space-time, and we want to map it into space-time.
Hmm.
Maybe the physicists can help us. Maybe the physicists have told us, if you can take your stuff and turn it into decorated permutations, we'll take it all the way to scattering amplitudes and like quarks and gluons at the Large Hadron Collider. So you just give us decorated permutations, we'll take you all the rest of the way. We said, thank you, thank you, thank you. So we need to take our theory of conscious agents, and we don't have to go all the way into space-time ourselves. We just have to go to these decorated permutations, at least to begin with. Then we'll study the whole thing, but at
Yeah.
least we'll get the connection. So a few months ago, I said, okay, so how do you map Markov chains into decorated permutations? Surely some mathematician has done that. So I did a literature search. No, there's no general theory about how to. So I said, well, let's do it. So Chetan Prakash, my friend and mathematics collaborator for over 30 years, we put our heads together, and it didn't take that long. We made a new contribution to mathematics.
That's
Of
awesome.
course, again, Chetan is the mathematician, not me.
Yeah.
But it's a new contribution to mathematics. We have a canonical procedure for taking any Markov chain and turning it into decorated permutations. So what that means is we can take our theory of conscious agents, turn it into decorated permutations. So it's a projection. It's an information losing map. So there's this rich dynamics of conscious agents. We give it almost like this trivializing projection down to decorated permutations. And in the process, we actually figured out what it is about the dynamics of consciousness that's being captured by the decorated. So I mean, that's something I could talk about too. But we actually now know what the decorated permutations are telling us about the consciousness, which is really cool.
Okay.
So, so then that allows us to go all the way into space time. But for a physicist, so suppose you're a physicist and you couldn't care less about conscious agents.
Right.
This is still interesting because what we've said is, look, the physicists have gone beyond space-time, but they've only found static structures. So the
Hmm.
amplitude hedron is just like this geometric object. It's just sitting there. It's doing nothing. It's just sitting there. Its phase structure codes the scattering, the codes for space-time and quantum theory, and the
Right.
volumes code for scattering probabilities or amplitudes. And the decorated permutations are just this geometric mathematics thing sitting there. Where's the dynamics? Physics likes dynamics.
Right.
So what we're saying is, look, you guys have gone beyond space-time. You found the deepest thing, the decorated permutations. There is a dynamics behind that. It's Markov dynamics. So whether or not you like consciousness, forget consciousness for the moment. Just dynamical systems of Markov dynamical systems give you decorated permutations. So there's this rich new era of dynamics that they need to study. And we think it's consciousness, but hey, forget consciousness if you don't like it. Just study the Markov dynamics.
So maybe the edge of geometry is going to get us into finding consciousness as
My thinking is that
it goes along with Pythagoras, doesn't it?
well, yeah, it does. And if the physicists don't like the notion of consciousness, they're going, and they do say we want a dynamics. They're going to have the question. Okay, this is a dynamics of something beyond space time. If you think about it, whatever it is, it's not going to be comfortable because we're not comfortable with anything beyond space time. So there's something happening outside of space time. Oh, okay, well, we're not going to be comfortable no matter what it is. I mean, consciousness might be the least uncomfortable
Yeah.
thing. So if
Yeah.
they don't like consciousness, they're going to have to posit something, and they'll probably get as many eyebrows raised as I get about consciousness, maybe more.
I think it's the right word to use because what other word are you going to use? Kerfluffle? I mean, what?
Well, so here's where you could go. You could say, look, we're going to posit these some kind of automata outside of space
Yeah,
time.
like cellular. Okay.
Yeah, like cellular. So maybe so it's not consciousness. It's just cellular automata that have this Markovian dynamics, and so in which case, fine. Then you have the hard problem of consciousness. Okay, so means
Yeah, you haven't solved anything. You haven't gotten to the
you
deeper,
haven't solved
more
that. Then,
fundamental
and
part.
if you're a physicist, maybe you go, I don't give a rip about the hard problem of consciousness. I was
Yeah,
just trying to get a dynamics. That's fine. But then the rest of us are going to have a problem. Okay, so the cellular automata, where do they get their consciousness? So
that's
so
right.
I like to just put the consciousness right in there as my assumption.
I think you mixing psychology and physics like you do is brilliant. I think that's every cognitive psychologist should be just as much into AI and physics and all the cognitive sciences, because it helps you figure out what you're going to try to find in science, you know.
More
Um,
tools, the better off you are.
you are absolutely correct, sir. I love you to death, man. I've loved talking to you. I don't want to keep you for too much longer. I think Nivik is in our call queue. He's been there for a while. This is one of our friends from the Pangburn Discord. Nivik, I'm going to let you ask like one or two questions, and then I think we need to let Don go, okay? All right, Nivik, you are on. Ask your question, sir.
Hi Don, how are you?
Good. How about you,
Um,
David?
I'm fine, thank you. I was wondering if consciousness is just the state of awareness of what's going on in time, what's going on in reality, and the more you're being stimulated in knowing what's going on, the higher your state of consciousness.
You cutting out a little bit there, Nivik.
The more you're aware of what's going on, the more the higher your level of consciousness.
So let's go back to the question. Is consciousness a state of awareness? Is that what you were asking him?
Yeah.
Okay. Let's let Don answer.
Well, so there are many different levels of consciousness in this theory of conscious agents. You could have a very simple conscious agent that has only the experience of red, or you could have a conscious agent that has trillions of experiences, or one that has a countable infinity of experiences, or even an uncountable infinity. And in fact, the theory seems to point that you could have there's this whole Cantor's hierarchy of infinities, and so you could imagine there's Aleph zero, which is the countable infinity, Aleph one, which is the first uncountable infinity, and then
Mm-hmm.
Aleph two. And there's no end to these infinities, and it turns out for each level infinity there will be conscious agents with that complexity. And so yes, they do differ in the complexity of how much they can be they can perceive. Uh, uh, some people want to talk about awareness versus the just pure awareness versus the contents of consciousness. So I might be aware without being aware of anything specific. Like there's no object that I'm perceiving, no color, no sound. I'm just aware without any content, and that's allowed by this theory. In fact, the theory, the mathematics of the theory of conscious agents actually starts with what's called a probability space. And that probability space, the way I interpret it, is awareness without any specific content. It's the potential for having any particular content that you might have, but the probability space by itself has no specific content.
You mean like an imagination? You're not really like actually taking anything from the environment. You can like have a lot of wild imaginative thoughts, and that itself be consciousness. You're not really having a state of awareness of what's going on around you.
Or awareness without any thoughts at all. So just pure awareness, no thoughts, just pure. So what meditation practitioners will talk about, like when you meditate for a long time, you can get to the point where you're aware and there's nothing that in particular that you're aware of, and so that's what seems to be this probability space seems to be for. And then the Markovian dynamics on top of that space would be what meditation practitioners or a lot of mystics talk about, is all
Mm-hmm.
the experiences that pop up in awareness and then disappear in awareness. They arise and fall down, but the awareness is there and it's sort of left unchanged. The awareness is just the awareness, and the experiences pop up and down. And that's what this Markovian dynamic seems to be. It's the Markovian dynamics of the specific conscious experiences that arise and disappear within awareness.
Mm-hmm.
So
I have a quick viewpoint
sure.
on evolution.
Nivik, real quick, bud, and we got to
Yes,
let
it'll
him
be
go.
real
Go.
quick.
Yeah. Go ahead.
I was always I was thinking like humans, they're different from animals, and animals like physically would evolve to adapt in order to survive in the environment. Human beings, the brain evolved, and it evolved in a way to manipulate matter as an extension of themselves. So instead of having to physically evolve like animals did in order to adapt to reality. You manipulate reality with our minds by taking information and being reasonable and
Okay.
and manipulate it as relative to us, to suit us instead of so we, instead of we have to change, evolve physically in order to adapt to reality. We manipulate, or we use our minds in reasoning and manipulating reality in a way that suits us instead.
Okay. Let him respond there, Nev.
Yeah, so that's a great idea, Nivik, and it's a very important idea in the theory of evolution that there's this that different organisms will face this trade-off, and they take different strategies. So the trade-off is I have a limited number of calories. Now I can use those calories to build a bigger brain. My brain, right now, the
Oh,
human brain uses up like 20% of our calories. It's a pig. It's only like less than 3% of your body mass, and it's eating up 20% of your calories. So it's a real pig.
Yep.
So the brain is a really expensive thing. And
uh,
so lots of organisms, there's a whole hierarchy here. So monkeys have fairly big brains, elephants have big brains, a squirrel has a smaller brain, and as you so different animals will spend more or less calories on their brains. The bigger your brain, the more problem solving you can do, and the more selective you can be in, for example, changing your niche, being clever about your food. If you're an E. coli and you don't have any brain at all, you use random search, right? Things are going good. And that can work too. But in that case, you're spending none of your energy on the brain, so you're not wasting calories on the brain. But your strategies are drop dead simple, and so you can see it's not just a 0-1 kind of thing. It's not like humans versus everything else. If you look over all animals and organisms, you'll see that that different that there's this trade-off. Humans have pushed the trade-off heavily on the brain side. Monkeys not quite as much. Squirrels not as much as them, and so forth. By the time you get down to ants, even less. And so the intelligence of their strategy may drop off. And by the time you get to E. coli, good luck, right? You're using random. You're depending on chance
Right.
a lot. So
Right.
so it's not. So your idea is a good one, Nivik. It's just that it's actually far more spread out than you might have imagined. This is a trade-off that's going all the time in evolution.
Yeah, man. Nivik, I appreciate you for the questions, my brother. We're gonna Don, you said you had we're gonna let you go a little early because you've been so good to us. I appreciate everything, man. I love your work. I think you're a brilliant
Thanks.
person. I want you to come back and talk to me again, talk to any of us again. We're
Yeah,
always on the Pangburn Philosophy Hangout, so please just come and spread your wisdom with us. Is there any final words you got to say to us, or?
well, no, just thank you. Thank you for your very kind
Oh,
invitation and great questions.
thank you, sir. Thank you so much. If you're more than welcome to stay and listen. I'm probably going to go for a little bit longer, but we're going to let Don go. Don, if you need to sign out, I think the best way is on the bottom right side. It'll say "Leave room."
Oh, very, very good. Okay.
Yes, sir. Thank you so
Appreciate it.
much, and
Great
we love you,
pleasure.
man. Thank
Take
you.
care. Okay.
Hey, take care. All right, Josh, you just joined up. What are you doing? Did you get to hear any of that? Anybody? Josh? Josh?
I'm here. I'm so sorry. I was on a message. I couldn't find the unmute button. Yeah, I heard a little bit of it.
Yeah,
Sounds
sweet.
good. My boy Nivik had some interesting questions.
Yeah.
You
Old
know how
Nivik
I.
had a couple. I would have let him go on longer, but I took up most of the time asking him my questions, and I didn't want to because he
Yeah.
said he needed to go, so I didn't want to keep him too long. But Nivik had some great questions, and uh, we covered everything that I thought he wanted to cover. All the questions I wanted to ask, I got to ask. So it was really good. I had a great time with that. That was really awesome. Thank you to Travis for letting me do that. Guys, we can continue talking, but I don't want to force anybody to. It's still pretty early in the day, so most people on the West Coast are still at work and shit. Here's old Jackaroo, my Jack.
That's because the West Coast is lame. Just kidding.
So,
Hello?
Jackaroony.
Hello? Can you hear me?
Yes.
All right. Yeah. Consciousness first theories have always nipped at me for many of the reasons that I think you can assume. They just
Right.
But it is it's definitely it's an interesting angle, but the only thing is like this if it's true to me and this thing, and whatever it is actually outside of space and time, then
Yeah, see, that's the thing I knew people would get on him for when he says
no,
outside of space and time.
I've got no problem with conceiving of it or like getting on with the idea, but it's rough to think that way. It's because it's just a hard sell to begin with.
It is a hard sell.
And so like with taking as much of like a grain of salt as I can against it and be like, okay, how can I think about this? I just get caught up in the idea that like it has to, like, if consciousness is first and this consciousness came from some sort of consciousness, but at the same time, the second that it goes out of our space time, it's not really beholden to those kinds of rules necessarily. So I don't, you can't just off the bat say that.
He's saying consciousness is what begets space time.
Right. I just,
yeah, I know. Like we talked about at the first of the episode, I said, could I associate you with the term that I made up called quantum monism, which is a form of neutral monism? And he said, yeah, you could say that. You know, so he says he's a consciousness realist. He thinks consciousness is real. All the other stuff is user interfaces that are that we see data structures with phenomenally.
Interesting.
Yeah, it is a very fringe view, but he's just started this. You know what I mean? He's in his.
It's definitely got my brain moving because
he's not a mystical guy either. He's not mystical
that's what
at
I'm
all.
saying. Trying to contend with this, like in my mind, and then separating it from like mysticism or religion is also difficult, just because that's kind of how it starts. And
if you watch his work, he is not going about it in any religious sense.
I don't think he is. No, that's why I'm separating it or doing my best, because I'm like, I know he's not talking about it from that angle. No. So it makes it I've got to separate some things that are hard to separate in my head, and then examine like just that separated and see if I believe it has any merit. The only thing that it kind of reminds me of is like the theory of the egg. Is the first thing that came into my mind when this was like when I started listening. If you want to explain what the theory of the egg is to everybody, because I don't feel like it.
I can go look it up, but I can't do it off the top of my cuff.
Oh, okay. That's fair enough.
You need Jesus, Jack.
Real quick for you.
Yeah,
you need Jesus.
Jesus was my grandfather's name.
We can talk about whatever, guys. I don't care. It's over now.
Well, I'm
okay.
interested to talk about this. I just didn't want to like. I knew that my.
Okay, so the theory of the egg. Are you guys ready?
Yeah.
The entire universe was created as an egg for the main character, quote unquote, all of humanity. And once you have lived every human life ever, you will be born as a god.
Essentially, that's essentially it is if you broke it down to like the bare minimums of it. But like, what essentially that it would mean to me is like if consciousness, you know, would be essentially like the background to us existing, right? That would be like the egg that we're in, right? As our like as we're growing, that background consciousness would be outside of space time and be like us developing essentially. Was it but that was the first thing that came into my head when I was thinking about that. But no, I can't. This is new to me to think about like without a religious angle. So I'm tackling
it. When I heard him say outside of space and time, you know where my mind goes.
Oh no, of course. Like I was instantly. I was like,
wait a minute. But
stop.
see, if everything is consciousness and it's begetting space and time through these user interfaces, then there is no outside space and time. There's just consciousness.
Right.
But he's not saying like in a panpsychist way where there's some extra substance called conscious or some extra particle attaching itself to quarks and leptons that's called consciousness.
It just would be those things. It just would be those things. It wouldn't be as something separately attaching itself to it.
Right. It would be those things. Yes.
Yeah.
Yes.
The Christian question for him is, how does he know there's consciousness?
Yeah, that's the thing, is he's assuming prima facie that there is consciousness, and that is the prime, that consciousness is a prime category. So we all have it, we all agree that we have it, but we don't know what it is, kind of thing, right? And so that is the biggest problem in psychology, when people in neuroscience and psychology and in cognitive psychology like him talk about consciousness. What do they really mean? You know what I mean? And that's the hardest
Oh
part
yeah.
to get at.
No,
Well, I would
it's
agree that we have consciousness. I wouldn't agree as to how we know there's consciousness as a Christian.
Right, right. Because mine would be through, mine would be through sensory evidence. You know, the fact that I am experiencing consciousness is the only way that I know that I have it. The only way that I assume other people have it is that they give me the same cues back that I give off, and I assume, oh, okay, this other person's a thinking agent. But with him, there is no self. It's kind of similar to how Honnenheim looks at it, you know, no self, just kind of like the philosophical zombie idea. But his is not that there is no will, it's just that there is no self. Everybody should look a lot deeper into his work, because it's quite complex. So anyway,
Do you think a dream is the conscious is the same as being conscious?
I would
Having a
say it's probably unconscious.
that's what I thought. I mean, I thought like if you're knocked out, you're unconscious, so it's just
Mm-hmm.
awareness. I mean, because if you're knocked out, you're unaware, right?
Well, that's a category error. That's not what they're talking about.
well, also aware is like relative to that, right? So like your brain, whether or not you're capable
Huh.
of registering it, is still registering things. It just
Okay,
doesn't
okay. So if you're
matter.
dreaming, you're conscious then.
The part of you that becomes aware of that
Okay.
isn't.
So if you're dreaming, you're conscious then, right? Is
Well,
what you're saying.
dreams happen in the subconscious, so yeah.
So there is processing in our
Oh,
brains
okay.
still going on while we're unconscious.
So it's just brain cells firing off is pretty much it.
Well, I think in this
Well,
case, when it comes to consciousness specifically, like with unconsciousness literally just means like not being aware of your consciousness, like for whatever amount of time. So if you know you're unconscious for an incredibly long time, we call it a coma, because you're just not consciously aware of your fucking surroundings. You know,
I mean, many people lucid dream, and I've lucid dreamed
Yeah.
before,
I
where I
have
was
lucid dreamed.
conscious. Yeah, where I was conscious in my dreams. So I think this state of unconsciousness, without too much mysticism, is still consciousness. You know what I mean? It's
Well,
still a state of just because you're knocked out, you're not dead. You know what I mean?
Right.
There's still processes. Your brain, when you wake up, is making sense of all the images and ideas and imaginations and things like that, and we make them into we put them into the stories that we think we saw as we dream. Right? It's not
Yeah,
like
your
we went to this
things are still
special
going on.
world. Yeah.
So like with somebody like, what was it, like Phineas Gage, right? Like
Yeah.
with somebody like that, right? Like his consciousness and the way he acted fundamentally changed after he got a fucking rod.
That's right.
So
That's right.
that means that if it's true that like this is the only way to like, it would have to be that the user interface of consciousness is so like wrapped up in the like physical workings, that if the physical workings get damaged anyway, you can't have the same level or the same type, or not the same level, but the same type of consciousness. Because the thing that confuses me there is that if we had consciousness coming from some sort of external source, to me, you wouldn't change just because some shit happened to your physicality. At least your
Right. No,
workings.
I agree with that. I agree with that completely. I think what he's, as easily as I understand him saying it, and he's very complex, but consciousness is real. It's an ontology. It's ontologically real. It is a substance. You know what I mean?
Okay.
Yeah. It's not just a state of awareness or some abstract conception that we have of our mind. You know, our mind has consciousness. No, consciousness is literally the substance that is birthing everything else, I think, is what I'm getting from him. That's what it all is. Like he said, he's taken. So the hard problem of consciousness, David Chalmers' hard problem, is that how do we get matter that has no consciousness, and then it somehow consciousness exists with matter that has no, individual neurons don't have.
With crazy fucking chemicals.
So
know.
he's going. So he's going. He's going backwards and assuming consciousness is first instead of physical matter, and saying, how do we get all these physical matter and user interfaces and data structures out of the consciousness? It arises from that. I don't necessarily agree with everything that he says. I just don't disagree because I haven't
Well,
looked at all of his evidence. You know,
it seems like it kind of moves along with the theory that like we don't think, right? Like, or thoughts don't come to, like, the thoughts happen to we
well, I
don't
mean, yeah,
have.
it does. He does kind of follow along with that, I would assume. I don't know where he stands on that, but I mean, we do know that at least in neuroscience, in terms of reductionism, we know that in neuroscience that thoughts happen faster than we can
Right.
conceive. So,
Which seems
uh,
seriously. This is another thing that I thought about. If that's the case, right, and there's this probability field that seems to come out of nowhere to create the potentiality for shit, and that probability field, the potentiality of this case would be like consciousness, right?
mhm.
Would it be that? Because that's what if it's everything, or if consciousness is reality, then that part of the
Mhm.
reality would be the probability field. So it'd have to be
Yeah,
consciousness.
that's what he was talking about with his probabilities. You know, he's saying the zero
Right.
probability, but that there's a line on this graph that can represent an infinite amount of many points
Mm-hmm.
in the probability of zero. So it
Right.
deals with fucking combinatorics, and I'm not perfect
Well,
at
then,
combinatorics, but
well, right, and then that makes me think of of a setup system, right? So I think that if there's a consciousness, or if consciousness is what it is because, I mean, what if it's just a fucking simulation? What if it's just the probability
exactly.
field? The probability field comes from this the create, like, whatever the engine or whatever it is that was made, technically outside of our, or not outside of our space time, but within, like, the
Well,
idea.
technically to him, it is a simulation because consciousness is simulating all those other artifacts.
Right.
So he's technically making a very general simulation
Simulation.
argument. Yeah.
Honestly, it's I mean, to me, the chances of that are going up pretty rapidly. Just watching
Oh, big time.
VR just get, like, more
Big
advanced
time.
every year.
I mean, assume in 200 years how realistic video games and simulations are going to be. I mean, imagine The Sims 2000. You know what I mean? Instead of and we can be in. There's a more likelihood
Roy
that
from
there's
Rick and
more
Morty.
there's a more likelihood in the future that there's more simulated realities than there is the actual reality.
I wasn't allowed to
So
play
it's
because they get naked.
there's a higher probability that we are in a simulated universe more than we are in the original quote unquote real universe.
You live in a
So
simulation within a simulation
yeah,
within a simulation.
yeah, the rabbit hole goes forever.
And honestly,
But
like, I think that at least for that shit has so many, like, amazing capabilities. Just being able to create fucking, like, universes and shit with technology. Like, hey, what's that old man that hasn't been able to walk for 40 years? And he's, here, how about this? You're a dragon now.
you're a dragon. Poof.
Do whatever you want. You're a dragon. Like, dude, what? Oh my god!
You're a fucking dragon now.
Like, whatever you want, or whatever you want. You know what I mean? But, like, just imagine, like, the raw difference in, like, life quality. But it's like, oh, instead of just being this person that, that's older, like, in a wheelchair or something like that, I can be a fucking dragon. Like, even if I can't do anything else,
Yeah.
that's fucking amazing.
I want to be a fucking dragon now.
Dude, I'm sure there's a fucking.
We
good
should have
VR
talked to
where you
Donald
can be a
about dragons. Be like, what do you think about dragons, dog?
dragon.
No, I didn't want to do that to him. He's that dude, man. Guys, in all honesty, is probably one of the most brilliant people we've ever interviewed. I mean, that dude has his hands in so many different pies. It's ridiculous, So
Yeah, he was a bit intimidating.
67. He's 67, and he's still this hungry for, like, learning and all. It's pretty impressive. So
I was struggling to keep up.
yeah, I know. You want me to be honest with you, Nivik? I don't know some of the terms that he used. Even after studying him for 3 or 4 days, this is what he does every day. He has lived it every day. So this is like talking about what you're going to do for your day over breakfast to him. This is, that's his profession. So
I see. It sounds like his lifestyle as well.
it is his
Like
lifestyle. Yeah. Oh yeah. I mean, when you're a scientist, when you're a cognitive scientist, you never turn that off. You know what I mean? So
I have a perception on time.
sure.
You you experience more time No, you
Experience
you
more
wait a minute.
time.
Okay, you okay. You are old. Okay, you have more. You gain more time by your experience. Yeah, that's what I'm trying to say. So
You gain more
in other
time.
so it's like you don't necessarily like it's not about the it's not necessarily about the length of time you live. You get what I'm saying? It's if you have a lot more experiences, in a way you live more. So you can
Well,
have a person that
how
can.
does that have to do with time as a physical object, though? You know what I mean? Because that's what he was talking about, like space time as an ontology, like particle physics and stuff.
Actually, I'm not sure what he was talking about.
No, it's okay. It's okay. Go on with what you were saying. I didn't mean to interrupt you.
No, I just had like a concept is all. I wanted to ask you what you thought about it.
Yeah, go ahead. I'm sorry.
No, I was thinking like, it's not about how long you live in amount of years. It's about the amount of experiences that you have, and in experiencing time.
Yeah, I mean, yes.
So
Um,
a person could go have more going on through their mind in experiences in a shorter amount of time than a person that lived a longer amount.
yep, that's true.
So
But
I mean,
but
there are
who
probably
says it's
plenty
all
of.
about your experiences? It doesn't. By what standard are you saying that? It doesn't make any sense.
Give a better example, Josh. Give an example if you
Yeah,
can.
he just said that his experiences are kind of like the epitome of what's going on. It's the foundation. Who told you that?
Okay, Nivik.
oh
Who told you that
you
your experiences are foundational?
oh me
Yeah, he was asking you based on your question. Ask it one more time, Josh. I'm sorry.
Yeah, so I guess what I'm trying to get at, and this is what happens with me and Nivik every time, is what's your foundation, right? What is your ultimate foundation for epistemology, truth, and morality, right? You're talking about experiences as though they are the foundation. Who told you that experiences are the foundation for what you know?
uh uh the, what okay, what I'm getting from the environment is is uh is how I know what I know.
Evidence in your senses, right?
Sure.
Yeah.
How do you know you're getting things from the environment?
um I my senses.
How do you know your senses, memory, and reasoning are not lying to you? And would that be bad if they were?
It is a good question to ask if your senses, memory, and reason lie to us, because we know the answer to that, Nivik, is yes, they can lie to us, right?
Okay. Well, um I
You didn't give a bad answer. I thought that was a good answer. Your senses. That's a good answer. Now Josh is asking why care about that, right, Josh?
a validation is
Yeah, absolutely.
survival. The fact that I can do it again and again.
Oh, you're a little quiet, Niv.
No, I'm saying my validation is my survival and the fact that I can do it again and again.
Gotcha.
Yeah, so survival is the goal of humanity. Survival is what you're going for. How do you know that, and why is that good?
You mean like what's my meaning? Is okay? I see what you're saying. Like my well, yes, that's my nature, and I'm supposed to take and the information I take from the environment is is uh what do you call it? I'm supposed to understand ramifications of what would happen, and and take that in as knowledge, and approach things from an understanding in order to survive.
Sure. Why are you supposed to understand that? Who told you that?
Oh, that's just my nature. Nobody told me.
Sure. So go ahead and define your nature for us, what your purpose is, and how you know that to be true.
My purpose. Uh, oh, okay. My purpose is to exist
That's a good one.
and to survive and thrive.
Yeah.
I take in meaning from the environment and understanding, and so I have more of an idea how to approach things in a way that is that could be beneficial to me. Because I it's from my understanding. I take in information and I understand how things. I understand. I take in from knowledge from the environment and understand how that knowledge relates to one another, how things relate to one another, and me, and I manipulate the environment in a way that would be beneficial.
Okay. I think Josh is busy. Jack, you still with us?
No, I'm good.
Jack, Captain Jack,
Yo, what's up?
were you still with us? I was just checking on you.
Yeah, no, I was just looking at some memes.
Post them in chat. Fuck it.
I can't do it.
We just hanging out now.
Is it can you get pictures in here? I don't think you can get pictures in here.
I don't know. I haven't tried yet.
I don't think you can. That's it.
Um,
But I think that it's a good idea to just not have that name. Just leave pictures. Probably not a good idea. Just spamming things in chat would be a little.
I mean, eventually there's just going to be a lot of spamming in chat when we get more people on this call-in beach.
Oh, for sure, for sure.
I can't wait till it's just like comments and you can't even keep up with the comments. It's just scrolling by so fast. Like you see all these Twitch people with like Jack, you know all these Twitch people with like 20 and 30,000 viewers per,
Yes.
daily. How in the hell do they communicate with their chat? You know what I mean? Like, how do you
Several
even?
mods did like lots and lots of programs, like insane amounts of programs meant to like do all that for you. You got like 5 people using 5 of the same program to like watch everything, and you got to pay those people essentially because that's like a job at that point.
Because I mean, a lot of my favorite Twitch viewers, they play Warzone and stuff like that. Like Patchouli, he only has like 500 viewers at a time, so he can directly keep up with his chat. But like, man, the tens of thousands people, I just don't even. Well, you explained it, but still crazy.
Most of the time, if people really want to be heard more than anybody else, they'll just do a dono. Like 9 times out of 10, you do a dollar dono, your shit will get at least like put up on the screen in like a more
yeah,
so you can see it. Most of the time, they have it set to like $2 to $5 to actually like have it come up. But
yeah,
that's usually the way that they can see your stuff if like you really want to get in there with it. But if not, you can just like spam chat with something until somebody tells you to fuck off. You're like, but then have them read it. And they're like, but fucking like I watch Dusty a lot with fucking is it the way I like the way he engages with his audience, because if somebody comes up with something, he'll hit him and be like, all right, I'm gonna give you 1.5 minutes to pull up like links and defend yourself and what you just said, and if you can't, I'm permabanning you, or you're getting like a 10-day ban or like a 3-day ban, and you gotta come back and be better next time.
Oh my god!
like if they start coming out of it like, I'm just like, that's like, I don't know how he can keep up with this shit, because he gets like, anywhere between like 3 to 9 to maybe 15,000.
That's ridiculous.
Hey, Tom.
Hey, bud.
Yeah, yeah, I was kind of like wanted to ask you a question. Like, if you could have lived, for let's say you lived for 3 years, and you didn't do nothing with your life. You just lived in a cave, and yeah, and then you had 40. You had like you could live for 41 years, but you travel the world. You've met a lot of different people, had a lot of different experiences. Uh, uh, experienced many different cultures. You know what I mean?
Yeah.
You had a lot of friends and associates and whatever, but the only thing is that you lived for you live for 41 years instead of 44 years. You'd take the 41 years, of course, right?
Oh, you're saying if like you had a better life at 41 years than at 44? Like if you had done more things and experienced more things, it'd be better to take. Is that what you're saying? I'm not really sure I
Yeah,
understand.
yeah, yeah. Like you never really done anything, and you have the option of living long versus a person that had a lot of life experiences, but
I
they
think
never
it's
worked.
different for every person, Niv.
And the question is, what's a better life? What do you mean by better? What's the standard there? What's wrong? What's right? It's an
Well-being,
epistemological thing.
personal well-being.
I didn't say better. I just said more experiences.
I want to take the life that has as many friend and loved ones experiences as I can get. That's what I'm looking for.
I want a fucking boat.
He wants a boat.
I want to, and I'm gonna go live on the boat. And what I do after that, I'm not sure, but that's gonna be fucking. I'm
The
gonna get my.
boat is the next ambition.
Was it? Well, actually, getting my lock picking certification. I want to start doing that. So,
You
is
gonna
it?
be breaking into people's houses?
I mean, not lock picking, lock smithing, but I will be learning at
I,
the same time. Is it?
I want to
But
be a good
I
lawyer.
want to do that and then get my boat and then just go wherever the fuck and be like, when I go places, I'm like, hey, you got locks? I can fix
Let me
them.
fix your locks, dog.
Hey man, that's almost everywhere. You can't go anywhere anyways without somebody wanting to keep people out of your shit.
That's true. This is a fact.
And I have another idea, but it's too good of an idea, and I can't just say it over the air.
I mean, we can move to Discord if everybody wants to. I just know that some of the people in here listening to us don't have a Discord, and just involving everybody.
Well, they better get it.
Oh, hey,
We can
invite them to the Discord. Let's go.
Just post
everybody.
it.
Well, no, I mean we've got Peter. I mean, a lot of people that we have in here know the Discord.
There's 24 people live.
Okay,
Yeah.
never mind.
Come to the
Post,
big
post the link.
It's almost as
It's
much as
amazing.
the Christian shows. It's pretty good, Thomas. I'm impressed.
Amazing.
Just
Do you
kidding.
know
I
the
love
link?
you.
I know you do. Nivik, do you know the link to the Discord? Can you post it? Because I don't even know where to post it from.
No.
Or Jack. Jack, you can do it.
Anybody.
I think I can find. Maybe.
I also know that you can go to the YouTube, Pangburn Philosophy YouTube, and top right corner, you just click the Discord thing, and it sends the link or whatever.
Bam. Boom. There's the Discord link for everybody if you'd like to join us on Discord sometime.
Yes. I guess since the show's over and there's really no topic, we'll just go ahead and move on over to Discord, guys. Thanks for coming and listening to me talk to Donald Hoffman. That was one of the best talks I've ever had. I loved him. He was fantastic. I hope everybody had a good time listening to him. For everybody in the future, please subscribe to the Pangburn Hangout. Please subscribe to the Pangburn Philosophy YouTube channel and come join us on Discord and hang out with us anytime. I am really glad everybody joined. Love you, and let's go to Discord.